Record me.
Mm-hmm.
All right. All right. So the first thing that we want to do when we are sampling is we want to make sure that we have the ability to record information. So there's no point in gathering data if it's not, recorded in some sort of way. So we always have a clipboard, and we typically designate somebody to be the recorder so that we know like how to track down data if we are confused about something. So Lily was the one that carried it, so she gets the fun job. So just make sure that you write your name, and the date is also important. And when you write the date, actually include day, month, and year, because sometimes I go back and I'm like, what year was this? And I try to guess based on other information. So yeah, we always want to record the data. You'll notice that she's recording with a pencil. If you're doing field work, you always want to use a pencil. Pen can run, particularly if you're using like a Sharpie or something. If you want the data to stay, use a pencil. We're not using waterproofing paper right now, but if we were out on the boat, we would definitely have waterproofing paper as well. Okay, so we're gonna start looking at our different equipment, and we're gonna start looking at some of the physical characteristics of the water. So the first thing we're gonna use is back there. Candace is holding an instrument called a Secchi disc, right? All right, so the Secchi disc helps us to determine water clarity, and the two different colors of the Secchi disc, kind of the contrast between that, allows you to see like how much suspended solids are in the water. So we use that very simply by lowering it into the water, and the depth at which you can't see it anymore is the depth that we're going to record. Okay. There are other instruments we could use to measure turbidity or suspended solids. This is the one most frequently used. It's super easy and very inexpensive. Okay, so each of those pink zip tie markings represents 1 meter. So the way I recommend sampling is to have it be a 2-person task so that we don't lose equipment. So usually one person holds the rope, and then the other person controls the instrument. So let's see. Amelia. Okay. So would you and Candace work together? One of you can put your instruments. You don't have to keep holding all of the stuff. So if you want to put the phone in that step. All right. So you're just gonna unwind some of the rope. All right. And that should be enough. Yeah. And so Amelia, if you want to move over towards the edge of the.
Sorry, I can't hear you.
Oh, I'm sorry. Okay. All right, so you're going to take the instrument, and you're going to lower it into the water.
Like slow, or does it like?
Yeah, it actually does super nice. Yeah, so relatively slow. And until you can't see it anymore.
All right.
Okay. All right, and so now you want to make sure that you measure from where it touches the water. So when you pull it back in, keep your eye on the location of the rope where it's wet, where it's touching the water, and it will also help you can actually feel where it's wet. But so bring it up and put your fingers where it touched the water. There you go. So that way you'll know the distance that we'll write down. If you're on the boat, usually there's waves, so it's sometimes an approximation, but so we've got 1 meter, 2 meter, so like 2 3/4 meters. So really, we'll write down like 2.75 meters. All right, so then you just wind it back up, and you have that done. Now, sometimes if we were sampling on a boat, and particularly like if we were sampling for a boat and there are limited people, like there weren't two people to do things. Usually there's cleats on the dock or on the boat, and so you can tie your instruments to that to make sure that you don't lose it. But I'm very particular about holding on to equipment because I have seen people toss things in the water thinking that it was tied off, and then it's just gone. So it's like, oh, there went $300, right? And it, you know, they're PhDs that do that, so it's not like, you know, it's not like they were just absent-minded sometimes, right? It happens. All right, so we're done with the turbidity. So we're gonna look at some of the other like characteristics of the water. We're gonna look at salinity and temperature. Now there's a lot of different instruments. Oh, and I meant to bring something, but I forgot. Okay, so there's a lot of different instruments that we could use. Use these. So there are, and I'll show this when we get back to the lab. I'll show you another instrument. We're going to use two different instruments to measure salinity. So the first one is really simple. This is a refractometer. There are kind of price points of equipment that you can use to measure salinity. The first one is, we have them in the lab too. They're called hydrometers. So they cost $5. They work just fine if you are an aquaculture, you know, connoisseur and you have fish tanks at home. They're fine. In most research labs, you'll find these. They're super easy to bring on boats, easy to use, pretty standard. These cost like $100 or $75. They work like a telescope. So we're gonna fill the bucket up, get a water sample, and to see what the salinity is, we put it up to our eye, and usually you have to kind of direct it towards the light because it measures the refraction of light, right? So we're gonna use that, and we're also gonna use this. It's just it measures pH, temperature, and dissolved solids as well. So it's just like a simple little instrument. We stick it in the water, and it records the temperature and everything. So we'll just try this out too. And we have another instrument. We use them in a lot of our labs. It's called a YSI. And so it's like a handheld instrument with a probe that extends into the water. So it's like this, but bigger. Okay, so, okay. DJ, you're closest. So, so what I want you to do first is just like dip in the water and dump it back out just to rinse it out. Okay, and so now just fill it up again. And you don't have to fill it like all the way up or like the top. Okay, so I've got two of these, and this might not be very exciting. Oh, actually it's much more exciting than I thought. It's a river, so sometimes it's like 0. Okay, so I'm going to pass this around. You can look through the little window and you'll see that it is blue on part of the top half should be blue. And then you'll see like a white part on the bottom. So with these, you want to see where the line between the blue and the white is, and that tells you what the salinity is for your water sample. that's not the most accurate of your instruments, but it's good. All right, so this has it has a little on button. There are many different types of these instruments, so you just follow the instructions of what an instrument has. And then, so the first thing that we're gonna do is we're gonna stick it in. And, oops, I turned it on. Alright, so the temperature looks okay to me. So it says that it's 20.5 degrees. But I think I need to recalibrate the pH. It's telling me that it's 2.8. I don't think it's 2.8. So we're going to have to calibrate the pH. And the temperature looks good.
And then what about the salinity with the refractometers? How do we like read that, I guess?
Oh, okay. So with the refractometer, so actually let me borrow that. Okay. So when you put it up to your eye, there is.
Yeah, there's like the D2020 and then.
Oh, right. Okay. The part on the right, it looks like a percent sign with an extra O. A percent sign means parts per hundred, like the amount out of 100.
Is it parts per thousand?
So it's parts per thousand. So it's like 21 parts per thousand. Right? The other part, the part on the other side, is density. So it's just it's a different measurement. But when we talk about salinity, we usually talk about it as parts per thousand. So we will calibrate this other machine before we talk about pH. That just works right. So we use this, so we got the temperature, we've got our salinity. All right, and the next thing that we want to do is we do our physical characteristics, salinity, and you wrote both the salinity and temperature down? Okay, fantastic. All right, so now let's go ahead and from our water sample, we are going to tailor. Oh, actually, I can take that refractometer. So we're going to use that. Okay. So that instrument, if you want to go ahead and take it out, it's called a handheld fluorometer. So it is just a simple machine that can give us a reading of like the overall fluorescence, so the chlorophyll that's in the water column. So this is kind of an easy machine that you can take out into the field, and it works pretty easy. So you're just gonna turn it on. And I use my shirts to dry things off all the time. So this is why we don't wear like fancy clothes. And then we just stick it in, close it, press read. All right, wait. Good, okay. So it's giving us the number 311.6. So what this does is it kind of gives us they are measurements that we can use in relation to one another. So this isn't like units of micrograms of chlorophyll, blah, 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 blah. It's something that we would have to compare to other things and then back calculate to a standard in order to but still very useful for us to use. Okay, so then you can just print it off. Thank you. All right, so that's, and actually, so that's like the machine that we would use if we were going out in the field. We will also take whole water samples, and we bring the whole water back to the lab, filter it out, and then we can do a couple of different things. We can do a chlorophyll extraction, so that we can look at chlorophyll concentrations using a spectrophotometer. And we can also preserve some of the whole water so that we can look at different types of microplankton that might be in the water, depending on what our So we're going to take whole water samples first, and we're going to use this instrument. We have a couple of these types of instruments. This is called a Van Dorn model. So once again, we've got the rope associated with it. Now I'm going to demo this one first because it's not hard, but it's got some little tricks to it. All right, so there are different shapes, styles, and materials that your water sampling devices can be made out of. This one is particularly good for sampling whole water if you want to collect phytoplankton or whole water to do things like nutrient chemistry, because there's no metal inside, it's all plastic. So metal, there are trace metals in the water, and so if you want to look at like the chemistry in the water, things that have metal in it are not so great. So this one, the type of plastic is good for those types of things. Some of the sampling devices are horizontal, like this one. Others are vertical. Really just depends on what your desires are. So if your the water sampler is lowering this way, it will sample like a meter long area. This just samples from a single discrete layer of the water column. So for this, we have to set it up. And the way that we set it up is that there is a push pin in the center. If you push this down, there is a pin in the front and then one in the back. You can see this one in the back pretty easily, it sticks out. But this one up here is the one that you want to pay attention to, because it will catch one of these loops. So in order to open it, you press down on this push pin and you bring up your one side. So this is pushed down. You stick this loop into that pin so it gets caught, and then you release the push pin so it comes back up. Then you've got another pin in the back, and when you are arranging this, you want to make sure that you don't like trigger this one, right? So you don't want to put your hand on this. You definitely don't want to put your hand over here, because if that snaps shut, you'll hurt yourself really bad. And then you want to pull this one up and loop it onto this other pin. Now, when you set it up, you want to make sure that your rope is always like free and not extended. So for example, if I, it would have worked better if I did it this way. So there are times that, like, if I hadn't, I did it like this. If I pulled up, then this would get all messed up. So you just want to make sure that your rope is free. So this is all set up. When we lower the water, we will use this device. It's called a messenger, and we will kind of toss it down. And the job of the messenger is to hit this pin with enough force to get it to close. So like that, it should end up closing. When deploying the device, sometimes depending on like waves and like motion on the boat, sometimes you have to like try it a couple of times because like the water slows the movement down. So you want to make sure that it hits it with enough force. So when you're deploying it, you really want to push it down so that it hits the pin hard enough. All right, so I think that was most of the advice about this. The other thing is that we have two nozzles. When it's open, the nozzles are facing in the same direction as the spigot. So it's not the end of the world if they're not closed, but it does mean that you might get wet if you bring it up to the surface and they're not in the closed direction. All right, so we're gonna go ahead and do that. So we are gonna deploy this. So I'm gonna let you do this if you want to. All right, so if you want to work with a friend, you're gonna be her friend for today. And so if you guys both get down on the ground, hold on to it, and then work together to like one of you hold it. Yep. Yep. And then push that pin down. Yep. Yeah, it's tight. Yep. You did it. Yep. Okay. Hold the other one.
Oops.
Oh yeah.
I'm so
That's
sorry.
that's why we practice. So just try it again. Okay, so this time you don't have to press it because you're going to use this one as a color. Yep. All right. And so you're going to be careful when you pick it up. Hold this in one hand, and then you like hold it from here, and then there you go. And then unravel a little bit of that. So you're going to lower it, we're going to just lower it so that you can still see it. So lower it until this part is in the water. All right, so that's good. Yep. And the deeper you like put it, the harder you have to, throw the messenger. And so when you throw the messenger, use your dominant hand. Hold the rope. Yes, perfect. Hold the rope with the other hand and use your dominant hand to like toss it down. Yeah. I don't think it worked. Oh, I didn't do it. Sometimes one side goes down and not the other. You just never know. There we go. Fantastic. Okay. So when it comes back to the surface, then we put water into the bottles. So we're going to put water in one of these. Depending on what we want to do with the water, we use preservatives. This we just want cool waters. We're going to use water. So with this part, we move this to the side, and then we have to open both ends. Oceanography is wet. Done with our sampling. There's actually, if you didn't want to do it that way, you just open. That was the fancy one. Don't get water out. If anybody wants to try this on their own, you are more than welcome. Do this. Anybody? Sure.
You want to try?
It's fun.
Here, do you want to throw it or do you want to set it up?
It's up to you.
Okay, you set it up.
All right.
I'll throw it.
Nice, nice.
We're gonna be here for a while. I'm sorry.
Is that far enough?
It is, yep.
Oasis.
It works. So one of the harder things about the boat is that we're moving. We're up and down and there's waves and it's like, I don't know what just happened. All right, so we don't need this water this time, so we can use it. But all right, so that. Oh, and the other thing that I wanted to mention about this is, so this is kind of small scale sampling. If we were on like an oceanographic vessel, there would be like an array of the vertical bottles. They're called Niskin bottles when they're that direction. And they're hooked up to a computer panel. They're lowered off the side using this big robot. And you just, you know, control them with a computer to deploy when you want them to. So this is small scale for sure. All right, the next things that we're gonna do are take samples so that we can see what type of organisms are in the water. We have two little nets, actually one little net and one big net, to catch little stuff and big stuff. All right, so PJ, will you grab that net? All right, so this net is, actually, display it for us. Yeah. So this net is tiny. This is like my Barbie net. It's super cute. This is a 30 micron. So that means that the mesh size of the fabric, the each square is about 30 microns. So really small. So our goal with this net is to catch small organisms, like phytoplankton and small, like unicellular eukaryotes. And that's partly why it's small. With this net, I don't have, it doesn't have any like fancy anything. When we use this, I usually use it just so that we can get like a qualitative description of what's in the water. Not necessarily how much is there, just what is there. And so with this net, we're gonna use it to sample. What else did I want to say? We're just gonna use it to sample. We'll grab some of it, the water, put it in the container, but we wouldn't quantify what is the water yet. We could use the whole water as a better way of doing quantification. All right, so if you want to grab that, you can, actually, so come on over here. And so this setup, put your wrist through there you go. So now you're not going to lose it. Okay. Everything, I have all of my tricks so I don't lose it. All right, so you're going to use a tension net. The trick to deploying that is to get the pod in so that it's full of water and that it can stay at or right below the surface. So I'm going to have you dip just this part of the net into the water, like up and down until the pod end fills with water. With teeny tiny. There you go. As you go up and down, more and more water will get out. Alright, so notice that none of the water went in the mouth. Okay, so that's important if you were going to do a quantification, because you don't want to start actually sampling the water, the organisms of the water, until you time it or start your measurements. But even though that'll matter more when you use it. All right, so for this one, when you're ready to start sampling, you lower it to the mouth, which is the big ring. Yep, it's in the water, and then you kind of take a walk to the end, and then whenever you're ready. since this has more water in it than the bottle, I'm doing this over the sample bottle, so all the extra just falls into the sample bottle. And another piece of advice, which seems obvious, but I'm saying anyways, is you want to make sure that you use a preservative bottle that is of a larger or equal volume with your hot end. All right, so to save us from a little extra when we get back and have to wash everything, we dip it back in the water just to rinse the extra like gunk out of the net. We wash it anyways when we get back, but like that's just like a field clean version. Put it back in. Okay. All right, and then our last sampling that we're going to do is with our zooplankton net. So this is a similar design. Let me So this is more like what you're going to actually use. So if you go out on like a research vessel, they will have nets like this or bigger, not like the Barbie one. So like I mentioned, this part here, this is the mouth. This is your net. This one has a different size mesh. This is 153 or 150. This size is best designed to catch zooplankton, so the small crustaceans, the main like heterotrophs in the water. The end, this is called a cod end. There are different shapes that you can use. So you'll notice that one was just a solid plastic bottle. That's called a non-filtering cod end. This one has mesh on it. I prefer this type when catching zooplankton because it means that my bottle doesn't get over full. And I can like filter the water before putting it in my bottle to preserve. So this one is a filtering cod end. The mesh size is the same mesh as the net. And that one twists on and off. This one clips on and off. So there's these little clips, which if you're working in Florida are just fine. If you are working in Rhode Island or New Hampshire in January, you will feel like your fingers are breaking when you are trying to take cod end on and off. So before you deploy this type of cod end or this type of net, I always recommend checking to see. I'm telling you all the ways that I've seen people lose equipment. So the first, always make sure that your cod end is actually attached. Also, always remember to bring a cod end with you when you're in the field. Otherwise, it's very complicated. Right, so those are two pieces of advice. So we are going to deploy this the same way. Except you'll notice I'm just going to demonstrate this. This is heavier and it's a filtering. So when you stick it in, it like automatically fills with water. So it's easier for that to like determine and know that it will sample the surface of the water. This net, and when we sample zooplankton, usually we want to be able to quantify it. And so the zooplankton net will always be equipped with, in our lab, will always be equipped with something like this. It's called a flow meter. And the flow meter is a propeller that spins as you move it through the water. And there's a conversion factor which allows you to use this to calculate the distance that you sample. And because this is cone shaped, you can use the equation for the volume of the cone to determine the cylinder, volume of the cylinder, in order to determine the volume of the water that you sampled. Right. So this flow meter did not work properly the last time I used it, so I will tell you another trick after this. But So you always want to write the flow meter start down. So it's 5070. But simultaneously, you also want to measure the time that you sampled it for. And if you have GPS coordinates that you can record at the start and end of your tow, everybody's got a GPS reader with them if you have a phone, then you are able to detect, to calculate the distance. And actually, I mean, we could calculate the distance of this by measuring it. So if you know the distance, you know the time, you will be able to calculate the volume of the water sample. All right, so just in case this doesn't. All right, so is there anybody that didn't do anything yet? Candace, did you do something? Did everybody do something? Yes? All right. Okay, I'll do two. Does everybody want to do this?
Sure.
Okay. You're my tow master. Okay. So for this, you just drop the cod end in, and you're gonna make sure that. There we go. All right. And so when you tow, see how it's kind of at that end of the net? When you lower it, kind of make sure that that stays in the water. Cool. All right, and go. Yeah, that's the last one. Okay.
What was in this box?
We're gonna, so those are to measure the nutrients.
Okay.
And I think I'm gonna have us do that. We're gonna take water back and we're gonna do it back in the lab.
Okay.
I think it'll go faster.
Okay.
Which is why I was like, why did we bring that up? That way everyone had something for us. Yeah. So right, the number of rotations have been calibrated, and they give you, when you buy it, they give you a chart to tell you how many rotations equal 1%. So it's been, I don't know how to do this. I just know that I get it.
Yeah, and because this has a filter, can you like more, I guess, more easily quantify it because based on your distance, because water's flowing out of it, and you're just left with like.
I think you can put it in any type of net. Okay, so it may not have, or may have. Ooh, gross.
Yeah, that was a lot of
All right, so let's see. It worked. Fantastic. All right, so it's 6053. Okay. So I don't really want to keep this. So if we were on the BIOS, there is like a saltwater hose, right? And we use that to kind of rinse the contents down so that we get like the most accurate amount of the organisms that we sampled. I don't really want to do that with this. But we are still going to save it just to see if there's anything in there. I'm just not hugely excited about Hillsborough River. Zooplankton. That's gross. Yeah. I don't know so much. Right. So a lot of times,
Say more.
so we're in the boat. When we're on the boat, we get a squirt bottle. We get the saltwater hose. We rinse that up. But I also use this trick. I have a bucket full of water, and as long as you can use that to rinse this out, as long as you don't submerge this. So you don't want the water to go in through the top, but if it goes in through the sides, then you're not getting extra zoning. Do that. rinse the net the same way. Put some different filter water, spread after. And then we put the cone end back on. Alright, so those are all the samples that we're going to do here. What we're going to do is when we go back to the lab, we're going to do this is a nutrient test kit. So it's a very simple way of testing things like nitrite, nitrate, and ammonia and the pH from the water. So we're going to do that back in the lab just so that because there's bench tops that are not here. All right. So whatever equipment you should carry back. And actually, we're going to bring